Betelgeuse, a star that has fascinated astronomers and the public alike, presents an intriguing puzzle in modern astrophysics. Its designation as a red supergiant situates it in a crucial phase of stellar evolution, one that marks the end of a massive star's life cycle. This stage is characterized by dramatic changes in the star's physical properties and its ultimate fate, which could have profound implications for our understanding of stellar phenomena and cosmic events. The life cycle of a red supergiant like Betelgeuse is marked by significant transformations. Such stars have evolved from earlier stages of stellar life, transitioning through the main sequence and giant phases. These stages are characterized by the star's core fusing hydrogen into helium, and as this fuel depletes, the core contracts while the outer layers expand. For Betelgeuse, this means a vast, bloated outer envelope and a core that is increasingly unstable. The core of a red supergiant like Betelgeuse eventually becomes so dense that it starts fusing heavier elements, such as carbon and oxygen. This fusion process generates immense energy, causing the outer layers of the star to expand even further. However, this phase is relatively short-lived on cosmic timescales, and as the star continues to burn through its nuclear fuel, it eventually reaches a critical point where it can no longer support the weight of its outer layers. This results in the core's collapse, leading to a supernova explosion. The conditions leading up to a supernova are incredibly complex. For Betelgeuse, the variability in its brightness and the recent extreme dimming are key indicators of the processes occurring in its outer layers. The changes in brightness can be linked to alterations in the star's outer envelope or interactions with its surrounding environment. Such variations might also signal that the star is undergoing internal restructuring in preparation for the eventual collapse. Moreover, the study of Betelgeuse provides a unique opportunity to observe the behavior of a star at the threshold of a supernova. By analyzing its light curves and spectral data, scientists can gain insights into the mechanisms driving its instability. The James Webb Space Telescope, with its advanced observational capabilities, is particularly well suited for this task. It offers unprecedented resolution and sensitivity in observing the infrared spectrum, allowing researchers to peer through the star's dense outer layers and study its inner dynamics. Another important aspect of studying Betelgeuse involves understanding the broader implications of its eventual supernova. When a massive star like Betelgeuse explodes, it releases an enormous amount of energy and material into space. This explosion disperses heavy elements that were synthesized in the star's core, enriching the interstellar medium with elements necessary for the formation of new stars and planetary systems. These supernovae also produce neutron stars or black holes, depending on the mass of the remaining core. The impact of a supernova on its surrounding environment is substantial. The shock waves from the explosion can trigger the formation of new stars by compressing nearby gas and dust. This process, known as supernova-triggered star formation, can lead to the creation of a new generation of stars and planetary systems. Additionally, the energy released can affect the dynamics of the galaxy, influencing the distribution of matter and the evolution of galactic structures. From an observational perspective, the imminent explosion of Betelgeuse offers a rare opportunity to witness a supernova event in real time. Historically, the study of supernovae has been limited to observations of past events. For example, the supernova SN 1987A in the Large Magellanic Cloud provided valuable insights into the nature of supernovae and their aftermath. However, observing Betelgeuse's transition from a red supergiant to a supernova would allow scientists to study the event's precursors and dynamics up close. In addition to the scientific significance, the potential supernova of Betelgeuse also holds a certain degree of public fascination. The star's brightness and its dramatic end are compelling subjects for both amateur and professional astronomers. Educational programs and media coverage of Betelgeuse's evolution serve to inspire interest in astronomy and space science among the general public. As a result, Betelgeuse has become a symbol of the dramatic and often violent processes that govern the life cycles of massive stars. As researchers continue to monitor Betelgeuse, they are also employing various other observational techniques to complement data from the James Webb Space Telescope. Ground-based observatories such as the Very Large Telescope, VLT, and the Gran Telescopio Canarias, GTC, provide additional data that helps refine models of the star's behavior. These observations are critical for building a comprehensive picture of Betelgeuse's current state and its imminent future. The study of Betelgeuse and other similar stars also contributes to our understanding of the broader cosmos. By analyzing the life cycles of massive stars, scientists can gain insights into the formation and evolution of galaxies. The processes that govern stellar evolution are intricately linked to the dynamics of galaxies, influencing everything from star formation rates to the distribution of elements throughout the universe. Furthermore, research into stars like Betelgeuse helps refine our models of stellar nucleosynthesis, the process by which elements are formed within stars. This knowledge is crucial for understanding the origin of elements in the universe and their distribution across different cosmic environments. It also informs our understanding of the conditions that led to the formation of our solar system and the elements that make up the Earth. In summary, Betelgeuse is more than just a captivating star. It is a key object of study in the field of astrophysics. Its potential to become a supernova offers a unique opportunity to explore the final stages of stellar evolution and the impacts of such explosive events on the universe. As researchers continue to investigate Betelgeuse, they contribute to our broader understanding of cosmic processes and the dynamic nature of the universe. The insights gained from studying Betelgeuse will undoubtedly enrich our knowledge of the cosmos and continue to inspire both scientists and the public alike. Expecting we eliminate the lines, the most captivating star I accept is the star that could be shocking in our sky. It is this one. A frightening little creature, press or bug crush, is a red supergiant star. If you put it where the sun is, it would extend to the orbit of Jupiter. It's enormous, totally sensitive, and going to explode. It's not exactly clear, as it has all the earmarks of being in the universe. These titanic events, like the most incredibly feared colossal starbursts, could significantly affect all that we see and don't have even the remotest clue yet. Betelgeuse has been viewed as a red, exceptionally monstrous star that is on numerous occasions more prominent than our sun. Brian Cox and other cosmologists figure it could go supernova at any second. People are generally unnerved by what will happen because the James Webb Space Telescope is taking staggering photographs of the star. When precisely will Betelgeuse become a supernova, and how tremendous of an effect will it have on Earth? Let us sort it out. A star in the constellation Orion shines so brightly that even people from ancient times have seen it. The imminent star Betelgeuse is located on the eastern shoulder of the constellation. Betelgeuse is the second greatest star in the constellation, and its name comes from this component, the monstrous shoulder. It is maybe one of the most brilliant stars in the night sky. On top of being very bright, the star is also a curious shade of red, which, as we will see, is what is going on. We have had some critical awareness of Betelgeuse for a long time. A Greek scientist named Tau also studied it. Around that time, the main thing people knew about stars was their color. OS said that Betelgeuse was an orange color. Astronomers have been studying the star much more closely lately, and now they have a smart idea of what works. One of these qualities is that the star changes brightness a lot, with a noticeable size of 0.6. Betelgeuse is a variable star, which means its brightness changes over time. Yet recently, researchers have found new data about the star. In 2019, specialists first saw that Betelgeuse was acting peculiarly. Despite the fact that Betelgeuse didn't totally stop shining, it wasn't the same since it had become considerably less bright, shining at an extent of around 1.6. Specialists promptly began to investigate why they were seeing the 10th most brilliant star overhead acting strangely. They had to issue an alarming statement based on their investigation, which concluded in the surprising signs the star has recently shown. Researchers say that Betelgeuse could go supernova at any second. Brian Cox, a prestigious scientist who offered this very dangerous statement as a professor of particle physics at the University of Manchester, is not kidding. He also has a science show, writes popular science books, and is the Royal Society Professor for Public Engagement in Science. Brian says Betelgeuse is like a ticking time bomb, as it could go off at any second. To make matters worse, the James Webb Space Telescope has provided a huge amount of evidence to back up this claim. What unusual signs has Betelgeuse given that have caused such distress in cosmology? Based on new information about Betelgeuse, the star has been classified as a supernova candidate, yet researchers are still uncertain when it will detonate. The fact that Betelgeuse is on numerous occasions the mass of the Sun is one justification for this classification. A star just needs to be on numerous occasions the mass of the Sun to be considered a supernova candidate. Things get even more interesting because analysts have used many tools to explore Betelgeuse, such as the James Webb Space Telescope and the Laser Interferometer Gravitational Wave Observatory, to see what is going on in space around Betelgeuse. What they have found is still fascinating. The Sun was born on August 31st quite some time ago. Around that time, the star Betelgeuse was probably giving off bizarre hints that made its future unclear. What did they find? They could detect odd light waves coming from the star or toward Betelgeuse, which is extremely odd. But this wasn't the only thing researchers saw about the star. This takes us back to the possibility that Betelgeuse is a star whose brightness changes. Sometimes it was said that Betelgeuse dimmed at regular intervals and had dark spots similar to our Sun today. Anyway, the situation is different now. It changes from bright to dim twice as quickly as it used to, which is another odd sign that Betelgeuse is back. Analysts found that the star's dimming cycle had hit a new brightness level of plus 1.61 in February 2021. This was just after the enormous dimming event. Recall how the star seemed to dim in an odd way in 2019. That is what we're referring to. This supposed extreme dimming was the beginning of Betelgeuse's odd behavior and made many people worry that Betelgeuse might explode. The degree of dimming was from 1.2 between 2019 and 2020, and the least degree of dimming ever recorded was in 2019. Researchers were certain that Betelgeuse would go supernova within the next 100,000 years because of the extreme dimming. There is a lot happening in the universe, so this is certainly disturbing. Researchers quickly changed their perspectives, but when they saw what happened next, Betelgeuse became brighter again after the extreme dimming and transformed into something even more striking. Astrophysicist Andrea Dupree at the Harvard-Smithsonian Center for Astrophysics says that the star is now 150% more luminous than normal, making it the seventh most brilliant star in the sky right now. Researchers were frightened when they saw a red glow in the southern hemisphere of the globe. Today, it still gets more interesting because this has led to different speculations about what caused the great dimming. First, it is important to note that not all stars have the red glow of Betelgeuse. The red glow of Betelgeuse is a sign of a red supergiant star, which is the last stage of a star's life and death. The red beam, on the other hand, is surprisingly caused by a surface temperature of around 3,500 Kelvin, which is much cooler than the Sun's 5,500 Kelvin. Since Betelgeuse is cooler than our Sun, it emits less energy per unit of surface area despite the fact that it is larger and close to exploding. Now let's examine what the extreme dimming looked like. Brian Cox wonders if this means that Betelgeuse will go supernova. The fact that Betelgeuse is a red supergiant already indicates that it is nearing the end of its life as a star. A dying star will also generally dim over time, which is something that scientists agree on. However, Betelgeuse's new odd behavior has made scientists even more concerned, and many telescopes are now focusing on the dimming. Still, things get more interesting because researchers don't yet know everything about Betelgeuse. Specialists are currently using the most state-of-the-art devices to watch the fascinating events occurring around Betelgeuse. The James Webb Space Telescope has been one of the best instruments scientists have used so far. Beginning in 2021, the James Webb Space Telescope has been in space and has helped researchers gather several significant insights about Betelgeuse. The new pictures of Betelgeuse's extreme dimming taken by this telescope have shown that the event involved a surface mass ejection 400 billion times greater than a typical coronal mass ejection. The James Webb Space Telescope can also look at things our eyes can't see, such as light waves and frequencies, and analysts are excited about what the telescope will find. Researchers have noticed dust clouds forming on the star's surface that look like leaves in space. This doesn't make sense. Despite the fact that Betelgeuse will die, specialists are still watching it since they don't know when it will go supernova. Scientists believe that Betelgeuse is numerous times greater than the Sun and that the brilliant red star will shine until the end of the decade. Yet, if we look at the many unusual things happening with the star, it is hard to say if this statement will still be valid after the extreme dimming. Consequently, researchers don't think Betelgeuse will explode soon. If Betelgeuse goes supernova, it will be the first such event we witnessed firsthand since Johannes Kepler did in 1604. Researchers also don't expect this to happen anytime soon, since they are still observing the star's odd behavior. Although scientists are certain that Betelgeuse will go supernova, when exactly this will happen remains a mystery. If we examine the universe without bias, one of the most captivating and possibly astonishing stars in our sky is Betelgeuse. Frequently referred to as Betelgeuse, this red supergiant star, if placed where the Sun is, would extend to Jupiter's orbit. It is certainly an enormous, unstable star on the brink of explosion. The universe doesn't operate solely through spectacular events like the feared starbursts, which could potentially alter everything we see. Betelgeuse has given intriguing signs as a red supergiant star that is many times the size of our Sun. Cosmologists, including Brian Cox, believe it could go supernova at any moment. The concern lies in the implications of this event, especially since the James Webb Space Telescope has captured disturbing images of the star. So when exactly will Betelgeuse become a supernova, and what effect will it have on Earth? We should delve into it. The star and the constellation Orion shine so brightly that it has been seen by ancient civilizations. The observation of a Betelgeuse supernova could also have implications for our understanding of the universe's expansion and the enigmatic force known as dark energy. In the late 1990s, observations of distant supernovae led to the discovery that the expansion of the universe is accelerating, not slowing down as previously thought. A Betelgeuse supernova, being relatively close in cosmic terms, would provide a valuable data point for studying the expansion rate of the universe and the role of dark energy in driving it. It could help refine our understanding of these fundamental cosmological concepts, possibly revealing new mysteries about the fate and nature of the cosmos. But what could be the potential consequences of a Betelgeuse supernova on Earth? Is humanity in danger? Considering the vast distances that separate us, this is an unlikely possibility. To put the size of our universe into perspective, consider that 1 light-year is roughly 5.88 trillion miles. Betelgeuse, at 725 light-years away, is more than 4,267 trillion miles distant from our planet. This enormous separation provides a degree of cosmic insulation, and any direct physical harm to Earth from the explosion itself is extremely unlikely. Thanks for watching this episode of Chronicles of Space.